Okay, finally, we are connecting uh, what we have discussed earlier to statistics. Okay, so it's like the final application. So using data, using probability, we make sense of our data, and using probability, we can finally derive what we want to know. Uh, Derive important information from our data set, okay, with the help of statistics. Okay, so we are just actually applying probability here. So this is a branch of mathematics that involves the collection, analysis, interpretation, presentation, and organization of data. And it provides methods for making inferences about the characteristics and patterns within a population based on a sample of that population. Okay? And it plays a crucial role in data analysis, providing tools and techniques to make sense of information and drawing meaningful conclusions. So we are usually doing either descriptive statistics or inferential statistics. And here, for now, we are going to focus more on descriptive because the next module focuses more on inferential statistics. Okay, so here, in descriptive statistics, we two of our most important focus or foci to two aspects that we focus mostly on are the measures of central tendency and the measures of dispersion. So in measures of central tendency, we want to represent the typical or central value of the data set, meaning we are doing that by calculating the mean, the median, and the mode. So, um, okay, we calculated use these are calculated using mathematical formulas or algorithms, and these are sensitive to extreme values. And the data types work well with interval or ratio data. Okay. Um, Not in okay, this is the common mistake in high school research and maybe in some other research, college or even professional research. Um, if we use Likert scale, we cannot actually take the mean of that. Okay, but um, it has been a common practice only that we we take the mean of the discrete or the ordinal values because Likert scale has ordinal values. So sometimes we just treat them as discrete um interval values. Okay, so that we can come up with our measure of central tendency. Okay, so measures of central tendency provides a single value that summarizes the data set. So actually, with the help of the mean, median, and mode, we can get the initial indication that our data set is normal or not normal, normal or abnormal. Okay. And when it comes to interpretation of results, measures of the central tendency represents a central tendency or typical value of the data set. So the typical, the centermost, if it is a normal distribution, so we have a bell-shaped curve, the centermost is our typical value. Okay. Usually we consider that as our target or our acceptable, most accepted value. Okay. And in statistical tests, we use this in various statistical analysis, especially in hypothesis testing. So before you can do inferential statistics, you need to do descriptive statistics actually. So both measures of central tendency and dispersion are actually performed before doing inferential statistics. Because descriptive statistics often includes these two and presentation to summarize and present data in a meaningful way, like whether the data set is normal or not. Okay. On the other hand, when we say dispersion, we are just talking about the spread or the variability of a data set, meaning how far from the center or the target value, how far are the other data, okay? How far have they deviated. Okay, so for that, we compute the range, the variance, and the standard deviation. And um, it works well with interval or ratio data also, and it provides a single value or distribution of values. Okay, and so on. In statistical tests, it is used in, especially in ANOVA, or it is very crucial in ANOVA. Okay, or analysis of variance. We're going to talk about that maybe in third module. Yep, third module. Okay, now um, let's have a quick uh illustration of what the mean, median, and mode actually does, or what they look like. Okay, the mean is the average of a set of numbers, and it is calculated by summing all the values and dividing by the total count. So, for example, if we have this data set, we have these values 5, 8, 12, 15, up to the last one. Then we just add them together and we just count them, how many of these. So we actually have 20 values. So divide by 20. And for that data set, we actually have a mean of 11.7. Now, the median is the middle value in a data set when it when it is arranged in ascending or descending order. So when we take the median, first we have to arrange it from the lowest to the highest, or maybe vice versa. So from there, we locate the centermost. And in this case, the most middle values are the 12 and the 12. So since we have an even number of values, or I mean even number, yes, even number of values, even number of data points, then uh we just take the 10th and the 11th. We just take the average of the two. So the 10th is 12 and the 11th is 12. So no need to take the average. But if these are two different numbers like 12 and 14, so you take the average of the two. So the median is 13. Okay. Now the mode is the value that appears most frequently in the data set. And in this case, we have 12, which appears most. Okay. You can count it. Maybe it's more useful if you look at your arranged or sorted data set, okay, in the median. That's why it's best you sort it first. You take the median first before the mode. So it's easier to locate, to determine which has the most values. And actually, okay, this one has is a multi-mode data set, because if you look closely, we actually have four 18s also, four 12s and four 18s. So 12 is not just the only mode that we have. 18 could also be the mode. So in this case, this is a multi-moded multi-mode data set, or multimodal data set. Okay? So unimodal if we only have one mode, multimodal if we have more than one. Okay? So we have more examples in our face-to-face discussions. This is just an introduction. In normal probability distributions, like what I mentioned, the mean, median, and mode are all equal. So if they are all equal or very close to each other, then we can expect somewhat like a bell-shaped curve. But if not, they will be skewed either to the left or to the right. So, um, okay, um, okay. Main statistical tests and models assume a normal or symmetrical distribution. So the rest of our course actually assumes normal distribution. And we're not going to discuss much on the rest. Okay, so skewed data may violate these assumptions. So that's why it's very important to test whether the data set is normal or not. If normal, then our assumptions could be correct. But if not normal, then if we apply the concepts that we are going to discuss, if we apply them to a non-normal data set, then the results could be inaccurate, okay, or even wrong. Okay, skewed data may violate these assumptions, potentially leading to biased results. And it impacts decision making, particularly in areas such as finance, economics and risk analysis. Okay, so when it comes to skewness, we have two types of skewness depending whether it's skewed to the left or to the right. If it's skewed to the left, then that's a positive skew, wherein the okay, it in a positively skewed distribution, the tail is on the right side, and the mean is this is the tail, by the way. This one, if you can see this, this is the tail. Um, and the mean is pulled towards the tail due to a few extremely high values. Okay, so here, positively skewed, the mean is greater than the median and the mode. While on the other hand, negative skewed um, data set, in a negatively skewed distribution, the tail is on the left side, so it's here, and the mean is pulled towards the tail to a few extremely low values. So here, specifically, the mean is less than the median and the mode. Okay, so kindly observe for you to better understand the concept of skewness. Okay, just remember before we can assume, especially when we are doing parametric tests, parametric statistics, we have to make sure that our data set is normal. Otherwise, we cannot do that. Okay, so another important thing is the standard deviation, which quantifies the average distance between each data point and the mean of a data set. And then we also have the variance, which is just the square of the standard deviation, which represents the average of the squared differences between each data point and the mean. So both of these are, as mentioned earlier, these are a measure of dispersion or spread. And the difference between the extreme data points is called a range. The range is actually the simplest measure of dispersion. We just take the difference between the highest value and the lowest value. Okay, so for example, if our okay, let's take a look at this data set first. So we have these data points, the lowest of which is 10 and the highest is 30. So if we are asked to find the range, we just subtract 30 uh um 10 from 30. So 30 minus 10, that's 20. So the range here is 20. And the standard deviation could be derived by taking first the subtracting first the mean from each of our data points. So in this case, the mean is I think zero point 0.9, 20.9 is here. So the mean is 20.9. So subtract that from each data point, and then we come up with this column. Okay. Now, each each what do you call that? Okay. Uh, each item here, you just square it, and then once you complete this, this is the square of this column. Okay. Once you are done with that, you have all the values already. Take the sum of the squared values and you divide that um from your um um okay, so long story. That's basically part of the process of determining the standard deviation using tabular approach. Okay, so you just okay, it's here. It depends whether you are computing for the population variance or population standard deviation, or you are computing for the sample. Um, if it's for the entire population, then you just divide this number, this sum of the squared values, just divided by the population. Okay? Or or if it is a sample variance, then you subtract one first. So if you have a sample size of 20, then population variance just divide by 20. Sample variance divide by 20 minus 1 or 19. Okay, so you can double check if it's correct here. So from that, we come up with these values. So as you can see, Excel is a very helpful tool for computing these values. But in module 5, you're going to see a better way. In just one click, you can actually derive these values, the range, the standard deviation, the variance. It doesn't have to be this complicated actually using Excel. Okay, so we're going to talk about that in module 5. In the meantime, the standard deviation actually determines the cortices of your data set. So cortices refers to how spread your data set is. So if it is um just normal, so our cortices is specifically described as mesokurtic. So if our data set is said to be mesokurtic, then it neither positive nor negative cortices. Meso, just right, normal. But if we have a positive cortices, meaning the data set is not well spread, they are very close to the center. Many of them are just almost the same as the center value. Okay, so we only have a very few values apart from the center. So um, that is also known as leptokurtic. Okay, if we have positive cortices, then the data set is said to be leptokurtic. On the other hand, if the as you can see, there are many uh, remember the the higher the plot, the higher the number of events that have such frequency or count. Okay, so for example, if uh here if this is the average value, then many of the higher and lower values are almost the same number with the average value. Okay, for example, if in an exam out of 100, if 50 is the average, then many other students got scores between 50 and 60, and many also between 40 and 50. So we can say majority of the students got a score of between 40 and 60 only. The rest we only have a very few. Okay, so uh, if it's a negative cortices, meaning it's not well spread. So we describe the dataset as platykurtic. Okay, so these are some of the important terms that might come out in our board exam. So that's why we just introduce it here. Okay, so lastly, we have the measure of position. So we are just dividing data sets into equal parts. So this is where the terms percentile, quartile, decile, and the interquartile range falls under. Okay, so we have the percentile. It represents the relative position of a specific value within a data set as a percentage. So for example, the 75th percentile is the value below which 75% of the data falls. And since 75% of 15 data points is 11.25, we can round up to 12. And therefore, the 75th percentile is the value of the 12th data point, which is 57. So we don't have the exact data set here, but this is just to show how the term percentile is being used. Okay. Similarly, we have the quartile, and the quartile is more common actually in data analysis. It divides a data set into four equal parts, each representing 25% of the data. So, for example, if you have this data set, the lowest and the highest, you divide it to four. So, the first uh, 25% is your first quartile or Q1. The second is your Q2. Third is your Q3, and the fourth is Q4. So we have four quartiles. And you can read the example there. Um, we have such thing as interquartile range, which actually used when determining outliers. Okay, and many other uses. Um, Interquartile range. Remember, we have in a given data set, we have quartile 1, 2, 3, and 4. So we just take the difference between the first and third quartile. So just take the difference between the three Q3 and Q1, and that's your IQR or the interquartile range. I just forgot to include it here. But you're going to encounter the term IQR soon once we are in the fifth module. Okay. Lastly, we also have the decile, divides a dataset into 10 equal parts. If quartile is divided into four, we divide the dataset into four equal parts. Decile, we have 10 equal parts. So this is not quite used in data analysis, but it's good to know also. Among the three, the quartile is the most commonly used, okay, because of such thing as interquartile range. Okay, so this is just a bonus topic, by the way. And lastly, we have an overview of inferential statistics. Again, I just would like to point it out that these statistical tests are only accurate when we work on normal uh, data set or a data set that has a normal distribution. Okay, so assuming we have a normal distribution, then when we, sige, let's define first. Inferential statistics may involve hypothesis testing. We're going to discuss that in the next module. And the module after that, regression analysis. Okay, hypothesis and regression on a data sample to allow researchers to make predictions and inferences about a population. Okay, so this is only possible once we are done with the descriptive statistics. Okay, so this is where we get meaningful information, but this is not possible without descriptive statistics. Okay, so when we do a statistical test, we first, one of the very first things that we should consider is our data. Okay, what are our variables and the data they hold? Okay, are they numerical in nature or categorical? If both of our variables are numerical, then that's the time that we can perform correlation test and regression. Okay, but if our both of our variables involve categorical data, then we cannot do uh, uh the common test that we have, or the what we call parametric tests. Instead, the simplest non-parametric test that we can do is the chi-squared test. Okay, categorical, like we are comparing um things in terms of um uh section or team and their um preferred choice. Okay, so on the other hand, if one variable is numerical and the other one is categorical, then that's the time we can do things like comparing things, okay, comparative tests, like using the z-test, the t-test, and the ANOVA. Okay, z-test if we have a large sample, t-test if we have a smaller sample, and ANOVA if we have more than two, okay, two or more groups to be compared. Okay, so this is just an overview. And in terms of correlation, we are basically measuring the relationship between variables, whether one variable is dependent on the other, whether there's a positive relationship or a negative relationship. Okay, and what, how strong is that relationship? Okay, because we can only make predictions if there is a strong relationship between variables. Okay, so that's all for this course. I hope you have learned a lot. I hope you understand now the power of data and how probability and statistics actually help uncover that. Okay, so thank you very much.